Good morning, everyone. Happy Monday. Here we are, last presentation on the evolution portion of this unit. And then tomorrow we will start our last unit, cellular respiration and photosynthesis, to wrap up the year. 2 weeks of school to go. Second last Monday of the year. Short, brief assignment to follow, a little matching, fill in the blank activity. All right, so here we go. Once again, we're talking natural selection. All right, and I think Charles Darwin and his finches. Charles Darwin came up with the theory on natural selection. All right, only the strong survive. Animals that become better adapted to their environment are more likely to survive. Right. Species. This is not a new term for you. All right. These are organisms that can breed together, and the offspring that they make can also be fertile or breed as well. All right. So, example, we have the tiger and the lion that breed with each other to make the liger. These are not organisms of the same species, the lion and the tiger. Therefore, the liger that is made could not have babies, okay, making them not the same species. All right, so moving on, this term speciation was also mentioned in Science 9. Quick review of it now. Speciation is the development of a new species from one species that already is living. Now you can think of the finches, the Galapagos Islands finches on this one. All right. Constantly different types of finches are being made due to the competitiveness between them for food and the different beaks over time that have been created. And a great example of speciation. All right. So we got the allopatric speciation. Sorry, I crossed that out a little bit there. Allopatric speciation. All right, is the formation of new species, like speciation is, but due to their location or reproduction possibilities. Okay, so this is allopatric speciation. All right, allopatric speciation involves three ideas or steps within it. All right. And one is physical barriers, as I will show you on the next slide, okay, with the rabbits. Geographical separation between two groups of the same species, all right, results in allopatric speciation. Also, natural selection. Okay, this was Darwin's theory. Separating groups makes them inherit differences, right? And once again, only the strong will survive, and through evolution, all right, and different pressures from the environment, all right, food sources, for example, different predators. And over time, all right, differences, physical and behavioral, makes them no longer sexually compatible. All right. So finches, for example, if separated between the different Galapagos Islands, they will no longer be sexually compatible over time. Right. So those are the 3 points that have to do with allopatric speciation. All right. So let's look at the rabbits here. Here we have a sample or population of white rabbits at the top. All right. Through allopatric speciation, this isolation, we separate the rabbits. Okay. Over time, we will have gray rabbits over here and white rabbits over here, two different species. Okay. Once reproductive isolation has occurred, these guys get back together. All right. They will not reproduce with each other. Once again, due to allopatric speciation. Finches are another great example. If they ever meet up again after being separated between islands, the Galapagos Islands I'm speaking, they will not be able to reproduce, okay, even though they are the same species. Now let me make this a little bit smaller. Slowly here, sorry. All right, so there's two theories on evolution, okay? And one is the most common followed one, second one, not so much, but some species have followed this one here, number two. But gradualism is the first one, all right, and this is the majority of the species on our planet, all right. Speciation takes place, evolution takes place at a slow, steady rate, okay, over time, and it's taken a lot of time. Gradually, the finches, their beaks have changed due to the competitiveness between them, sources of food, etc. Okay, so gradualism is the most common theory that we on Earth here follow. But there are some organisms that have went with this theory or followed this theory of punctuated equilibrium. All right. Now, punctuated equilibrium, let me move this way. Okay. Involves two major points, really. All right. So, most species evolve very rapidly in time. Okay. This is the punctuated equilibrium. All right. So, let's look at the butterflies here. This is the gradualism right here. Okay. Gradually, new species over time are made as shown by the colors. All right. Punctuated equilibrium. All right. There is really fast evolutionary change here at the start. So fast speciation, or an initial burst of evolution. And then there's a long time period where nothing happens due to these species becoming very well adapted. Okay, that's this space in here before we got the new species of butterflies. So we got the fast burst of change, okay, followed by the long, significant time period where nothing takes place. So we got the gradualism and the punctuated equilibrium, okay. Remote, small, isolated locations and populations is usually where punctuated equilibrium happens. Okay, moving on to the next slide. All right, now we've heard the term biodiversity for many years in the last, I don't know how many years of science, probably since science 6, 7, 8, 9, science 10 as well. The majority or the most biodiversity on our planet, okay, is found right along our equator, the nice hot weather rainforest area right along the equator. Okay, that's where the most biodiversity is found. But there has been evidence, okay, found in the Burgess shales, and this is found in our very own Rocky Mountains, okay, that there's been found. Sorry, I can't even speak anymore. Okay, these fossils have shown for 515 million years, huge diversity since this 500 million years ago, this Cambrian era has taken place. So a lot of biodiversity along the equator, the most on our planet, but more and more biodiversity is being shown, especially in the Rocky Mountains, just due to fossils being found, all right, in the last 515 million years since this era right here. All right, so moving on. All right, so we have two types of evolution here that we're going to finish off with. The divergent evolution, a great example of that would be our finches, okay, organisms that live in different environments, being each of the different Galapagos islands that these finches are found, okay, they adapt differently due to food source, okay, so organisms that live in different environments, divergent. Okay, I'm sure you can think of the second type, and that is the convergent, okay, organisms that are totally different, but they live in similar environment and adapt similarly, okay, and remember this term analogous right here, okay, same features on their body, okay, same functions, but totally different organisms. Shark's fin, okay, same purpose as a penguin's fin, okay, or wing. Okay, dolphin's fin, for example. Okay, they all have the same purpose here. This is convergent. Okay, moving on. Here's a quick review of the convergent divergent. So convergent, this would be this one here. We got the shark, the penguin, and the dolphin. Okay, different ancestry. All right, species are unrelated. Right, different ancestry. All right, they're analogous. Okay, as opposed to the common ancestors and this close relation of the species as the finches were. Okay, so we got divergent and convergent. Now, last slide here, second last slide. One new term here. Extinct is definitely not new to you, but extant would be. All right, so these two things show that evolution has taken place. Okay, extinct organisms that are no longer found on Earth. Okay, extant organisms or extant organisms, animals that still are in existence, so exact opposite of each other. All right, and these two things show, all right, that evolution is constantly taking place on our planet. An example of extant right here is the peppered moth. I don't know if you remember this from Science 9. Now, the peppered moth changed over time due to heavy, dark, black pollution, all right, in the air, okay, and has changed from gray to black, and it is slowly changing back to gray due to the cleanliness of the environment. But here we have the peppered moth, okay, gray, I guess, well, grayish brown, changed to black over time due to heavy pollution on the trees that it lived, and it wanted to blend in with its environment of the dark bark on the tree. Okay, so slowly these peppered moths are turning back to this brownish gray color. All right, once again showing evolution exists from extant animals that are still living. All right, bacteria also is another good example. More and more resistant bacteria when antibiotics are given, and bacteria is becoming resistant to these antibiotics. Okay, over time, your antibiotics are not working anymore. Okay, and I think that's it. That sums up the last lesson on evolution. Okay, extinct, extant. Remember those two, convergent and divergent. All right, the definitions there. This is an important slide as well. Right here, two theories on how evolution has taken place. We got the gradualism, slow, steady, and we got the punctuated equilibrium, where at the start we got a fast change, okay, followed by a long period of time where nothing took place. Okay, and allopatric might be a new word for you as well. Speciation, as is species and natural selection, or not. All right, I hope everyone has a great day. Happy Monday.